All right, we are in Geometry A, Unit 6, Congruent Triangles, and Lesson 4, Using Corresponding Parts of Congruent Triangles. So basically, this is a new phase in proofs. So far, we've been trying to prove that triangles are congruent. Now we're trying to prove that parts of triangles are congruent. So we have a pair of congruent angles or a pair of congruent sides that we want to prove. The outline of these proofs is all the same. 1, prove the triangles congruent. You've got to have congruent triangles to use this rule. And then 2, use CPC TC. CPC-TC simply stands for corresponding parts of congruent triangles are congruent. CPC-TC. C, P, C, T, C. It's another way to say the definition of congruent triangles. What is the definition of congruent triangles? It's two triangles that share or have corresponding sides that are congruent and corresponding angles that are congruent. You remember we started this unit by defining what it means for triangle CAT to be congruent to triangle DOG. It means all the angles are congruent, 3 facts. It means all the sides are congruent, 3 facts. Okay, so 6 total facts. And we gave the shortcuts for proving those triangles are congruent as side, 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 angle, angle, side, angle, 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 side. And shortly we're going to add hypotenuse, leg. But all of these are shortcuts. But if the triangles are congruent, we know their parts are congruent. CPC-TC is just a short way to say the definition of congruent triangle. Let's do an example of this kind of proof. Okay, so let's take a given scenario here. Let's say we've got two parallel line segments here. Okay. And we've got these intersecting diagonals, so to speak. Okay, and we have the following information. We know this is parallel to this. Okay, and we know this side is congruent to this side. And let's label this side, the vertices A, B, C, D, and E. So given segment AB is parallel to segment DC, and AE, segment AE is congruent to segment CE. And here's what we're going to prove. We're going to prove that segment AB is congruent to segment CD. I'm going to prove those are congruent. So, as with all proofs, we start by saying what was given, right? So we have our statement and our rules. The very first statement will be what's given. AB is parallel to DC, and AE is congruent to CE. How do we know those are true? They are given. It's the only assumption we can make in all the proof. Given. We're going to end with what we're trying to prove. AB is congruent to CD. Okay? We don't know the reason yet. Actually, I think we do. But we know it's CPC-TC. Corresponding parts of congruent triangles are congruent. Okay, remember the outline of the proof is to first prove the triangles congruent, then use CPC-TC or corresponding parts. All right, that said, let's go ahead and do this. All right, so there's a couple of things I know right off. Statement 2, just thinking about this. You look for bow ties in Siamese twins, and lo and behold, there's a bow tie, right? Vertical angles. So angle AEB is congruent to angle CED by the vertical angle theorem. Vertical angles are congruent. Don't call them opposite angles. They are not opposite angles. Opposite angles refer to a different kind of angle that we're going to deal with when we get to quadrilaterals next semester. Vertical angle theorem is the name of the rule. All right. So let's see what we've got here. We've got an angle congruent to an angle. We've got a side congruent to a side. That's two facts. That's angle side, but we need something else. So let's go with this. We know the lines are parallel. We know the lines are parallel. So angle A has got to be congruent to angle C, because when two transversals are crossed by when two parallel lines are crossed by a transversal, these two angles, called alternate interior angles, are congruent. And that's what we've got here going on. Alternate interior angles. So step 3, angle A is congruent to angle C. We can get away with one letter because it's non-ambiguous. There's only one angle at those vertices. 3, how do we know they are congruent? Because the alternate interior angle theorem says so. Lines are parallel, and they're crossed by a transversal. Okay. And so here we go. We've got an angle here and an angle here. It looks like I've got angle, side, angle. Angle, side, angle. And let me make sure they're all here. We've got the angle, the side, and the angle. So all three parts are in the proof. So I can now say, statement 4, triangle ABE is congruent to triangle. What goes with A, C. What goes with B, D. What goes with E, E. Okay. Step 4, the rule that says they are congruent is angle, side, angle. And now that I've proven the triangles are congruent, I'm ready for the last step. And this is the only step that's really new. If we know the triangles are congruent, that means their parts are congruent. Okay? So I can say, step 5, AB is congruent to CD. Segment AB is congruent to segment DC. Segment AB is congruent to segment DC or CD, because corresponding parts of congruent triangles are congruent. Okay? You could also technically say by the definition of congruent triangles, because the definition of congruent triangles is triangles whose sides are all congruent and angles are all congruent. Quod erat demonstrandum. I said it, therefore I proved it.